everyone, welcome to today's stream. Pretty excited today. I'm on a bit of a high because there's some cool new features in Prefect Core, so I'm pretty excited to show you. And another fun thing about today's stream is that both of the features I'm going to talk about today start with the letter R. So the theme today is that these are Prefect features brought to you by the letter R. So hopefully you can enjoy that. I've even named all of my little desktop stuff the letter R stream so I could keep everything straight. So that's pretty exciting to me, at least. But the two that I want to talk about are resources, which is actually something new in 0.12.5. So that's kind of like the newest thing to hit. Definitely the newest thing with a letter that starts with R, with a word that starts with R. And then the other thing I want to talk to you all about today is results, which may seem a little bit like old news to people who have been hanging around Prefect for a while, since it did get a major refactor in 0.11 and we're already in 0.12.5. But there's been continuous improvements on how results have been working since then. I've got some pretty cutting edge stuff that I want to show you today that has been happening with contributors actually. So gonna peek a little bit at that. And then in any case, I think it might be nice to just go through some of the result stuff that may have come out in 0.11, but we haven't really done any sort of video content about it. So I want to make sure everybody kind of sees how it all works. So let's start with resources and then we'll move to results. So what I want to show today is this resource manager. And let me actually pull up the docs for this really quick. So this is a feature brought to us by Jim, who I believe is actually in the chat today. So you can say hi to him if you want and tell him how great this is. So the whole idea behind this feature is that you can set up in your Prefect flow using this resource manager API things that should be temporary, so maybe Dask or Spark clusters, virtual machines or Kubernetes deployments, different Docker containers, whatever, some sort of thing that you have a Python SDK that you can start and stop. And then we provide, I'm going to scroll down a little bit here, we provide this interface basically that you can use to describe how your resources are supposed to be initialized, how they're supposed to be set up, how they're supposed to be cleaned up. And then scrolling down a little bit more, you can use this context manager here to instantiate resources of whatever class that you've created. And then we take care of making this startup task and this cleanup task for you based on however you describe that up here, instead of you putting them in yourself. And I'm going to show a pretty basic example. By comparison, I'm sure there's a bunch of crazy stuff that you could do, like flip different things between different resources. And it's really most useful, it kind of says here, for defining resources where the cleanup needs to be monitored and managed by Prefect as a task in your flow. So especially for things that are expensive, like cloud resources that you want to make sure actually get cleaned up and you don't, definitely I think there are a lot of people who may have some tooling around their Prefect flows to start and stop stuff. And this might be a nice, easy way to ease that stuff into your Prefect flow so it's actually managed as part of the Prefect lifecycle, and then you can get all the useful, state handlers that you love, the UI that you love, to introspect how that stuff is actually working for you, instead of it kind of not being first class in your flow if you're using these outside tools to create them. So that's the whole idea. And there's an example in here about creating a temporary Dask cluster using this, but what I'm going to do is actually connect to a standalone Spark instance that I'm running on my laptop to just show you how that looks in that case. So let me pull it back here. So I've got Spark installed and running actually. So let me show you my dashboard, right? So here's my dashboard of my Spark master. I have a worker running in the background. So this is a Spark cluster that is ready and available for work. And what I want to do is submit jobs to it. And first I'm going to do it in the generic Spark way. So I'm using some of the example stuff that comes downloaded when you install Spark. So if I want to start up, let's see, in here, there is a tool here called Spark Submit, which is going to submit some job written in one of the Spark SDKs. In my case, I'm going to use, there's an examples directory, which it's in main, Python. There's one in here called word count. that I'm going to submit to my Spark cluster here, just using their tooling, right? So here is like Sparky stuff that's coming out to talk about what's going on. Also, I called this wrong. This file here, we can actually go look at it. You can see this is the actual source code of this. Expects to have a file passed in on the command line. So the whole thing that it's doing basically is submitting as a Spark job to read that file and count up the number of words that are in it. So what I'm going to do is call it properly. And just for fun, there's a README in here, the README for Spark, that I'm just going to pass that as the thing that it should count words on. So anyways, here we are. Now Sparky stuff is coming out. You'll see that there's a lot of information about what's going on. Eventually we're going to see, because there's some print statements in this file, in this Python file here, all of this stuff is a printout of the output of the work that was done by Spark to count up all of these things that are inside this README, right? So, not super interesting, but you could maybe get a more interesting corpus at some point if you want. But that's the idea of how to just generally run something with Spark. So what I wanted to show was to do the same thing, take this code out of, in my example here, right, we have it in this example that came from Spark, is in Spark's examples directory. And I want to take out the actual Spark work in here and make it a prefect task. And then all of this stuff here that's starting and stopping a Spark session, I want to instead configure those as prefect resources. So I'm going to use this nice resource manager API to start them and stop them. And I don't have to put those in line inside my task or use some other tooling to do it. It's instead just going to be in my prefect flow. So let's take a look at how that looks over here. And while I was at it, I also threw in a couple other steps in this to also send me an email of this output, just to throw in some extra flavor of prefect in here. But what I really want to zoom in on, right, is this section here, which is this resource manager. So this is, again, maps very directly to what's being talked about in the docs here about what the interface is for whatever resource you want to describe. So in my case, I'm making this new class, my Spark session. I tag it with this decorator, right? This is kind of how it gets notated. And then I have three things to work with, three methods to work with: the init method, a setup method, and a cleanup method. And the init method is going to take any sort of configuration that I want to expose at initialization time. In this case, I have this thing called app name. If we flip back just to look at the Spark source code version, you'll see that there's this app name that gets created to create the Spark session. So that's something sort of at the configuration level of my Spark session that I'd like to parameterize here. Then this setup method is going to actually create the resource. So in this case, it's using this Spark session from inside PySpark.sql to actually create an instance. It's straight from the example before, but this could be whatever the SDK is for you, for whatever tool that you're using to create whatever resource that it is. So this is going to return this object, which I've named Spark in this little example. And then the cleanup method here, it's going to take whatever the resource is as a argument in. So this is going to be my resource object. So I can then call whatever I need to on that to do whatever cleanup is required, or run whatever code it is that needs to clean up whatever this resource is. Conveniently for me, right, in this example, I just need to call a stop method on that. But it could be more complicated, right? It could be whatever you need to put into cleanup. And with these three things, if we scroll down and skip over all this for a second, we'll see that I have this flow. Here's the magical part, that has a Spark session instantiated with this context manager that sends in this Python word count string for my configuration for my app name and aliases it, right, to this keyword Spark. And then that I have configured my word count task to take this resource in as a argument as well. We can see that matches up here on line 28. So I can take that object, and then it will do the Spark stuff it needs to do. I've basically just taken the meat of the code from our source over here, our example source over here, and stuffed it in this task instead. And that's how this is handled from the perspective of the flow code. So if, for example, let me switch over to my prefect life, right? So I'm going to drop into a Python shell really quick, and from word count flow, that's the name of this flow I've been showing you, import f, just to show you the visualization. Visualize, f.visualize, there we go. Okay, so this is our prefect visualization of all the things that are going on here. And you can see that now, right around this sort of bubble where the word count task is, that's where this life cycle of this resource is being turned into tasks for me. I didn't, explicitly make those as task instances. That's what the resource manager, decorator on my class, and context manager in my flow did for me. So all of this is you can kind of see even in the visualization, it's like sort of injecting around on this word count because that's the specific place in the flow that I need that specific resource. And you can imagine that this could also happen with longer flows where you maybe need one resource for this whole section of tasks, maybe you need another resource for this whole section of tasks, however you want to split it up. So this is, kind of the simplest case, but you'll see that it's sort of wrapping around this life cycle easily for you with this nice API. So that's what's going on here in the background. And in my case, I've also added in two extra sort of prefect-y things. I've put in a parameter to take in the file name of what I actually want to be calling this word count code on. And then at the very end, I added an email task that's going to actually email me out this sort of like semi-nicely formatted version of the output, just to showcase that some of the niceness of this is that I can still use, this Spark cluster to do some of this work, and then I can layer in other nice prefect stuff that I like using the task library, like using parameters or what have you, using anything else. But this resource management can also happen for me in this nice API, and I can get sort of everything that I like. Of course, I'm Prefect's biggest fan, but I can get everything that I like all in one file, all in one piece of flow code, all in this visualization. So it's really easy for me to reason about, is kind of the exciting part of that. So let me close this, and we can actually run it too, just so you can see that I'm going to, what did I call this? I already forgot, word count flow. Word count flow, right? So I'm gonna run this. If I just scroll down, I'll show you that down here, I have f.run, and I'm gonna be running this against my file name parameter as the same file that I was using before, Sparks README, and then you can probably see the spoilers down here, but I'm gonna do it with the prefect README afterwards. But here we go. So if I press enter now I'm doing this with my flow code, right? So we see all of the prefect stuff that we're used to seeing, but we're also seeing some of the Spark output too, because that's actually coming out from the logger of PySpark. So if we scroll up and look at some of these logs for a little bit, you'll see that these tasks, which we saw in the visualization, even though we didn't explicitly specify them, they came from the resource manager lifecycle, are being instantiated for us. And for example, the setup task is running for us. And then later on, here's our Spark output. Later on, our setup task finishes. Then our word count task actually starts and finishes. And then this cleanup task, right after we get item from, let's see, right in here, right? This access here. Then this cleanup method, right? This is the name of the task for the cleanup method, which then gets run, and that's what's actually going to get rid of my session. And then in this case, just general email task at the very end. So this is sort of the evidence too in the logs that you can see these things having their natural prefect life cycles as tasks themselves, which then means that you can use them, as tasks as you're used to. So also, since I threw in some email, we can go check my email, right? See that here I use my email task and I got this sort of, formatted example. So this is, all the stuff from the output from my Spark job. And then if I want to change this up, right, to, spell it right, to instead use the prefect readme as the file that we're actually going to call this word count on, save that, and then if I run this again, same thing. This is just normal parameter stuff, but this is going to send that as the parameter to my word count task, right? And so eventually, we can go check my email again together. Where did I put that? Back here. Go check my email. See, I got more email for myself. Right? But here is the word counts from Prefect, right? We can see we've got a few more emojis. But yeah, so here we can see more Prefect-y stuff coming out here in the word count results. So that is the gist about the resource manager, and hopefully a nice example of using it with Spark in particular. But really the magic here is that we can use this nice context manager. We can, separate out this code about actually standing things up and tearing things down into this nice class. And then you don't have to worry about making the task. We'll worry about making the task for you. So that's the idea of the resource manager. It's the hottest thing off the presses. Again, it's only in 0.12.5. So you should definitely pip install -upgrade and get a hold of that so you can try it out. So that's the story for resource managers. Let's turn our attention, let me close this, to results, right? So I have a couple things I want to show you about results. Let me organize my notes here, which I also have in a different Conda environment. So let me just get myself organized, right? So we're going to, not caps lock, right? Conda deactivate spelling. Cool. And then I have over here in my letter R stream directory another spot called results, right? Because everything is starting with the letter R. So I have some examples in here that I want to use to show you what's going on with results. So first, let's double check the docs again. Oops, don't run that. Here are the docs for results. We kind of have two things, this section for results, and we also have a tutorial about using results that goes a little bit deeper into the configuration. But here we're in the core concepts results spot. And this is where it talks a ton about what this result object is even about. So for people who maybe aren't used to it at all, result objects are where the return value for any prefect task is automatically attached into a result object, which has a bunch of nice things like methods and attributes around it that give us the possibility to persist that data elsewhere, to use cached data, for example. So all of that functionality is kind of tied up in this results API. But if nothing else, you can definitely access these result objects directly if you have access to your flow object your state object from your flow after it's been run, and sort of inspect these as raw Python objects. But they also have their utility to serialize and deserialize external data for you if you want. And that's what I want to talk about today. So if we look at the nav here, this result objects explanation starts up here, but eventually we get to this persisting results section. And in particular, I want to talk about pipeline persisted results, which is that if you turn on this feature called checkpointing, then these results will attempt to write themselves down somewhere. And you get to configure that based on a couple of different backends. So we have like a local result to store on your local file system, S3 result if you're S3 user, GCP result if you're GCP, Azure result if you're using Azure Blobs, all that type of stuff. And you could also subclass your own results if you have some other type of persistence or specialty ways to write or read things. This is the configuration that I want to start from sort of where it was in 0.11 and eventually take you to kind of the newest stuff today. So we're going to effectively kind of walk through aspects of this how to configure task result persistence, which is first that you're going to need to pick a result type. I'm going to show you local results to keep it easy. And then you're going to support where things are written with either just plain result locations, which I'm going to show you, or targets, which is a very sort of famous tooling in lots of different pipeline frameworks and is now officially part of Prefect as well. So let's take a look at those. Let me pull up the actual code. It'll be easier to follow. Okay, so a couple things here. I have my results directory over here because I'm going to sort of show you some magic of making some files, right? Because the whole thing I want to show you is about persistence. And the first step here, the first version of this that I want to show you is with a super basic flow, right, that really only has a task that says hi and then returns the value, hi, or howdy, sorry, says howdy, then returns the value howdy. And here on line 11, you'll see that I start my flow context, and I associate with my flow context a result argument, kwarg, that in my case, again, I mentioned I'm going to be using a local result, is an instance of a local result class. And in my case, I've also set the dir attribute on that to be this thing location dir back in line 9, which I have set to be this directory, blah, 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 letter R stream, right, results, location results. And that's the part that I'm going to open up over here in my Finder, just so you can see it. Okay, so what I'm going to do is in the back here, let's get a little bit more organized so it's a little less crowded, so we can enjoy the full thrill here, is, move this up, that I'm going to run this flow, right, this location flow, Python location flow, right? And I have nothing over here in my location results right now. And as this runs, then we're hoping to see our location results show up, but I bet that I probably don't have some of my settings set up properly to do so. So a couple points to make about putting something in location, right? We need to have some config set for checkpointing equals true. I actually have it set over here. So this is an important step which often gets missed. So that's why I thought it was the first problem that I had, which is that you have to turn checkpointing on if you're in core. If you're using cloud, then checkpointing gets turned on by default for you. But if you don't, then you need to at least put this. And that's usually 99% of anybody's problems with checkpointing in particular. Okay, so let's see. One problem that I actually see is that I'm not in my Conda environment where I have some stuff that I need. So let me do that first and see if that's my problem. So this one's called results, I believe. Yeah. All right, let's try this again. Make sure we're operating properly. Okay, there we go. So interesting. I guess I must have something in base, something in results that I don't have in base, but I would have thought I didn't have prefect in base. So forensics for later. Okay, so hopefully you caught that over here. Now you see that this file has shown up. I have checkpointing set to true in my prefect config, which got read when I started up prefect. And then I ran this flow, and then you'll see that this file exists. We can actually kind of take a look at it. So it's actually a cloud pickle, so it doesn't really like show up that great, but it so happens that I have a bunch of ASCII in here, so it's gonna kind of render. So I'm gonna just show you results. There's this file right in here that has, you know, some other formatting stuff that's getting rendered weird on my terminal because it doesn't know how to decode it. But we at least see that this howdy got in here, right? And that directly is tying to the fact that this is a Python string that has these characters howdy in it. Why did I pick howdy? I don't know. So the interesting thing about this, right? So I've said when you run this flow, make a local result in this directory, right? I'm saying use my local file system, find a directory that matches location dir, put something in there, right? So I can actually keep running this over and over again. Oops, not cat. Run my flow over and over again, and we're going to keep dropping more files in here because I haven't said anything about what about that file besides where it should go, and there's some built-in stuff that basically makes a new unique file every time. So something that you might be interested in, even at this level, just in the sense that these files exist at all, is to give an actual name. And the way that you're going to do that is in here, right, where I'm passing these attributes to my local result. I'm also going to pass in another one called location. And this can be just file name.txt if you want, or whatever it is. But usually the most exciting thing is that you can also name it with a string that's going to be templated with any sort of like normal Python templating or with anything that's in your prefect context at the time that that task is run. So for example, to showcase kind of both of those, here I'm going to use the date that comes from prefect context and format it with this type of formatting, which is going to give me just the name of the day of the week. And then I'm going to also use the task name, right? So this is also something that comes in context that's going to be associated with the task name that's either auto-generated for this task or that I could put myself. And then just to, be cute and match the docs, I'll also end that with .prefect as our file type, kind of also to distinguish. These are still, in this case, they're going to be pickles. So, I'm kind of like cheating and catting them out to the terminal anyways, but that's not really what it's for, right? So I'm going to press save here just so you can see, and remember, let's keep our Finder over here so we can watch the magic happen live. But if I hit this again, you'll see that now we have created something else, this Friday directory, and inside here there's this file hello prefect, right? So I could, just to like quick and dirty show you, go in here, showcase this file, howdy, right? And you'll see that it's there. So one thing I do want to point out is that since I'm using these two things that maybe aren't changeable enough for how often I'm planning on running this, if I, for example, change some of this, let's save that, and then run this again, I'm not going to create a new file because the properties, the dates, day of the week, and the name of the task have not changed, but the content that's actually in that file has changed. This is another thing that I just want to warn people about because you can get yourself confused. If you're using just these vanilla locations just to store these files so that, perhaps they can be used from cache, if you don't use a naming convention in your template that's going to vary enough by how often you plan on running them, then you're at risk of overwriting them, right? Because it doesn't really do anything intelligent about checking to see if you should right there. It assumes that it should if you've provided a result in a location for that result. So FYI, that's the other kind of potential gotcha about here. So that's a nice sort of segue into another way to use prefect results, which is to establish a target, which is a file that if it exists, then this task should not run. And if it doesn't exist, then this task should write its result to that location. Same thing as what normal locations do, but in this case, we're layering on the fact that if that file already does exist, like in that situation, we just simulated over here where we did an overwrite, if it actually exists, then if we use the target technique of setting up and configuring our result, then it won't rerun the task, it won't overwrite. So the way that this has changed is basically that this formatting here, right, this templated string that I want to use for my location, I've pulled it out of the initialization of my local result, and instead I've added it as a kwarg on my task named target. So once you put a target on a task, then that's the preference in terms of if a target or a location is specified for the result that's associated with that task. And what I'm saying by setting this kwarg here is, hey prefect, when you get to it, right, when you run hello, can you check to see if a file matching this string, formatted with the arguments at runtime, if that file already exists. If so, don't try and do the task, set it into cache state and just read the value from that file. But if it doesn't exist, if I haven't done this work before, or if I have but somebody's deleted my file, then actually write it down to that location. So same style as how location works. So let me sneak out because I have made a new directory called target results to showcase this, and you can see in line 9 that I've flipped here what my location dir is pointing at. So that's, bubbling down here to my local results initialization. And if I run this, again, get everybody in a row, I'm going to run target flow. Remember what it's called. If I run this, we'll see that files appear right over here. I can click in here and see that there's a hello.prefect. If I, again, let's make sure I go to the right place, target results, right? Friday, hello.prefect. If I, just take this kind of quick, dirty look in here, we'll see that it says howdy. So this is where I want to show that, let's say I change this, right? I change my task code, but I leave this file here. And, Friday hasn't changed. It's still Friday. If you're watching this from the future, it may not be, but it's still Friday here. My task name hasn't changed, right? So for all intents and purposes, I would expect my target to be considered still existing when I rerun this, even though I've changed code in my task, right? So if I hit this to run this again with my new directions, you'll see, and we can kind of look deep in here to make a comparison between when I ran it before, when I didn't have this file, and now when I do. When I ran it before, you'll see that my task hello started, it printed out this thing that I put in my task code and said it was finished with state success. But now the second time, you'll see that it says it's starting this task run, but it immediately finishes with the final state cache, and it doesn't print out high like I might have expected based on the fact that I set that in my task. And if we take a look at what is actually inside this file still, it still says howdy, right? Because the whole life cycle here was that the prefect pipeline was like, I'm going to try and do this hello task. Wait, there's a target. Let me check that first. And goes, looks at that file, and then sees that there's something actually there, and is like, oh, I don't need to do this work. Cool. And let me set this to cache state and just move on. So our code that we changed here on purpose because of targets, because of our configured targets, didn't run. So I want to point that out in particular, and then also point out that if I remove this file, right, so if I make this file not exist here anymore, changing nothing else, I can run my target flow again, and we're back to the state where when it checks for the target, it's not there, so it decides, okay, yeah, I can run this task, and we'll see this output here, starting task run. You'll see it says hi to us because I've changed my code. It says that it's in state success, and this file has reappeared here from my newest run. We can just look at it one more time and see that it does indeed have this word hi in it. So that's the idea of targets. And these two examples, the location life and the target life, have this nuanced difference about whether it's going to use the fact that that file exists to arrest task progress, to whether it's actually going to execute or not, arrest task execution, I guess I should say, or not, if it's just going to keep, always executing, and this is just a way to write files down. So depends on your use case, of course, what you want to do, but that's the idea. Targets have, been widely used in other pipelining frameworks I mentioned before, can be really useful if you want to, take a more active role in terms of getting rid of files, to be able to change the state of something from cached to actually running. And I think that's something that people are really used to from these other tools as well. So hopefully that is a useful case for you. So the last thing I want to show you about results is kind of an extra nice to have because we're live streaming, right? So I can show you whatever I want that's the newest and latest and greatest. So I kind of want to take the opportunity to talk up another aspect that you can configure, and then show you what some contributors are actually doing on the open source side of Prefect Core, people who, just fans of Prefect who are using it in their day-to-day, and then they're PRing in changes. So I want to show you one of the sort of hot new live serializers, even more fresh off the press than resources, because it's not even in a release yet. It's not even in master. So we're gonna take a look at that and do a shout out for everybody who's been working on that. But let me explain serializers in general first. So implied in here with my local result is that there's going to be some way to encode basically into bytes to write down, and also that we know how we're going to decode it back into our deserialized Python object. And across the board, the sort of first line of defense that we ever created internally in Prefect is to use Cloud Pickle. So we've always used Cloud Pickle for that. So if you, however, want to use something else to do the serialization or deserialization, so easy idea is like using JSON instead to dump to a string or load from a string, then you might write a serializer to describe how does that serialization happen, how does that deserialization happen, right? And then this is something that you can attach to any result subclass. So for example, here I have my local result, so I could pass in a serializer here to configure how it's working, right? How that serialization, deserialization actually happens. So what's exciting is that the work in progress by the contribs, I'm going to show you the PR over here. So it's a couple folks have been working on it. At Andrew Rook, at Jackson Maxfield, at Bob Kolner have been, talking on different issues. A couple other contribs have also been, putting in their 2 cents. Definitely a couple folks throwing in their like thumbs up emojis or like rocket emojis or whatever too. So lots of folks excited about using Panda serializers. Probably a lot of you are used to using data frames, using like the to CSV or from CSV functions in there, or all the other ones, to Parquet, etc. So if you were hoping that you could get your stuff written down in a Pandas way and get it read back up in a Pandas way, then you're in luck, because people are actively working on this. And again, since it's a live stream, I can show you the latest and greatest if you want. So I actually have a flow here that runs on this branch. So I'm going to go check it out over here. So I need to go get into my prefect directory, because I'm on master right now, but I want to check out. I have already checking my spelling here, right? Even though I'm tab completing, I'm still checking my spelling. I have already pulled down this branch, and I also, my results conda environment here is in editable mode. So this means that I'm operating against this branch here that has this serializer in it. So we can actually go take a really quick look even in this file that got changed. The important file, most important I would say, is this file here that introduces this Pandas serializer class, right? So this is in source, prefect, engine serializers, right? So somewhere in here, right, is the Pandas serializer. So I pulled down these changes to my local, and again, I'm in editable mode in my conda environment. So this is, whenever I'm running Python, I'm now using this branch. So let's get back over here into my results directory, because I want to run this flow that depends on the changes that are in this branch. Right here, this is the magic. Well, I guess it starts in line 3, because I try and import Pandas serializer, which only exists in this branch. And then down here, you'll see on line 14, just to kind of space everything out so I don't have really long lines, I create this serializer, and I instantiate my Pandas serializer, right? That's from the branch. We can kind of see over here is a quick way to take a look, that when we instantiate the serializer, we get to pick a file type of what data frame serialization and deserialization method we want to use. So all of the to blah or from blah, from underscore CSV to underscore CSV, all of those methods are being exposed to us through this file type argument. So I'm going to say CSV, which means I'm asking my local result, hey, when you run this hello task or any other task in this flow, can you go and make a file on my local file system? That's local result, right? In this directory, right? In my example, I made it this targets result directory, and using this serializer, right? So when you actually convert this Python object to bytes, use the serializer's to bytes method. Otherwise, if we're reading, then use the from bytes method. And that's how all of these things are kind of working in concert together. So to make this, work, I've put together this thrilling 3-line task where hello no longer prints hello. Instead, it makes a random data frame with random numbers in it, prints out the head of that data frame, and then we'll return it. And this part is the fact that there's a return value that is a data frame is what's going to make the final connections between, oh, hey, I'm a task that returned a data frame, so it's time for me to use my local result. And then because, you and I have configured it to work as a Pandas serializer, then it's going to be able to call the convenience methods on that data frame that conveniently change it like to CSV or to JSON or to whatever. So just to keep myself a little bit sane, kept in target results, but I put a new directory name in front called pandas just so we can see that happening. So I'm going to need to back up here. I'm still inside my target results directory, but we're expecting to see a new directory show up here with my file in it. And if I just go back here and hit it, right, Python pflow, then we'll see that, stuff got generated over here just to make us feel sane. Again, I printed out the head of this data frame so we can see that it exists. And if I jump in here, then I see that there's this file, hello.prefect. And if I go so far as to cat it out, let's remember target results pandas. Friday. Hello. There we go. You'll see that this is a CSV, right? This is straight, you could just read this, right? You could open this in Excel if you wanted to. This is just a normal old CSV, and the magic that's happening there is that this didn't get turned into a pickle and then stored. This doesn't look like a bunch of gibberish because it's a pickle. This looks like a CSV because we serialized it into CSV format by using the Panda serializer. So to kind of showcase that again, I'm going to, let's see. Let's delete this file, move to trash, right? Because it's a target, so I want to override it because I'm going to change this one file type argument here to show you that if I change this to JSON, for example, this is a valid option because there is a to.json and a from.json method for data frames. If I save this and run my pflow again, then we'll see this file appears. But if I cat it out, now it's JSON structure instead, right? Because I changed my serializer. I told my serializer that it should write this down as JSON. And in our case, it took advantage of the fact that the Pandas people already made a thing that does that. But you got to configure it just straight up in your prefect result here by changing the serializer. So that's, the hottest new stuff. Thank you to all the contributors who have been working on this, because this was definitely the first serializer idea to kind of hit the scene. In fact, what really happened was that a couple, some amount of weeks ago, we actually got a pull request about a pandas result, right? Because we had the results class from 011, and definitely people needed, Andrew Rook in particular was the one who came up with that PR at the time. And as we were reviewing it, it came up that maybe we should separate out the concept of the serializers and the result object itself, so that it's the job of the result object to know what storage backend, right? I'm using local, it could be S3, GCP, blah, blah, blah. But it's the job of the serializer to decide how do we get to bytes, how do we get out of bytes, and that kind of separates those concerns so you can configure them in many more possibilities, right? So that conversation all happened on that PR, which meant we kind of had to take a bit of a sideways veer and instead work on creating the fact that the serializer class should exist at all and could be attached to results internally inside the prefect pipeline. So worked on that, and then now that interface exists, which again you could use to create your own serializers in your own code base if you wanted to, but now it's time to pull in the Pandas serializer, taking some of the inspiration from the Pandas result, combining some of the thoughts from, again, a couple different contributors who have all been working on this for a while, and get it done, right? Get it in prefect. So I really like this story because it's a good example of people who are really using prefect, who want to make it extensible. We want them to be able to make it extensible, right? So they see results, they decide to extend it to a result type they want, and then there's even this even tighter feedback loop to be able to then take that observation and realize that we need some more changes to make this more configurable, more easy, more extensible for people, and then circle it all back around again. So I think that's a good story, and I think it's fun to be able to show you the latest and greatest in a live stream. So that is the whole show for today. Let me refresh my chat window down here, see if anybody's asking me any questions. But that's what I wanted to show you in the stream brought to you by the letter R, right? So if you get a chance, or if it's useful to your workflow, then I definitely recommend taking a look at these new tools, right? So everything related to results and everything related to the resource manager. And especially, serializers are pretty new. I showed you the cutting edge. Resources are totally new. So if you are using them and something's difficult or hard, or you have questions, or if you're extending them and you want to see if that's a good compatibility to merge into core or anything else, we want to hear what's going on with you. So definitely come find us on Slack. Definitely come find us on GitHub, and keep kicking it around, because we depend on everybody to kick it around and let us know what they like and what they don't like, and are totally open to making changes. So definitely take a look at these. I don't know if we'll get another chance to have a stream that is sponsored by a letter of the alphabet in the future, but who knows, maybe we will. So with no further ado, that is it. And thank you so much for stopping by, and I will see you next time. Bye.